of continuing on this like trend. I had done some presentations back a while ago. One was on like dtplyr. So that was like all these things sort of themes on taking dplyr code and trying to find like different ways to improve performance and stuff. So like dtplyr was like dplyr with like a data table backend. Then I had also done more recently stuff with like DuckDB. So the DuckDB package in R. And this is today I'll be doing sort of like a mix. It's almost like a mix of those two packages, duckplyr. And I think it was sort of like inspired by, I guess, weaknesses in the purchase or in those two previous packages, DuckDB and dtplyr. So I think this is a good option here. So I guess I sort of put together a vignette. So if you want to follow along, I linked it in the rstats sheet. It's like it links to like my repository it's this rstats duckplyr directory. There's an R markdown and then HTML. So GitHub doesn't render the HTML. So I'd recommend just like downloading it, and then that has like the actual full vignette. So that's what I'll be doing today. So I'm just gonna be walking basically through this vignette for today. So I put my opinion in here a little bit. I think duckplyr, so far as I've tested it, it seems like it's a good, basically a performance focused drop-in replacement for dplyr, where you don't really have to change much of your dplyr code. Although I will show that some things are slightly different in syntax, but for the most part, you take dplyr code and it runs it with this DuckDB backend. I think it's a little bit different than dtplyr for reasons I'll get into. I think the translation is a little bit more reliable. But yeah, so let's just jump in. Like I said, duckplyr is sort of integrating between this DuckDB, which I discussed a couple of stats sessions ago, and dplyr. So you can, for the most part, write your same dplyr code. And it does something similar to dtplyr, where it does everything in a lazy way, where you write the code, it doesn't actually run it until you need it. And then by sort of putting together like if you have a bunch of pipes and you're doing a bunch of different operations, DuckDB can sort of optimize the entire query rather than executing everything eagerly like dplyr will. And then you can sort of control how things are materialized into R. So there's different settings, which I'll get into, where you can be very strict if you want and sort of have it refuse to materialize things unless you are very explicit. So, I mean, the whole idea, though, is that you get dplyr is really optimized for expressiveness and clarity of code. So it's not really optimized for memory use or speed. So we're trying to get sort of the best of both worlds here, where you get dplyr expressiveness and then some better performance and better memory usage. So the way you use it is pretty simple. You might import your normal packages, including dplyr. The dplyr is included in the tidyverse. And then you just attach the library of duckplyr, and that does some stuff behind in the background. It's not quite overwriting the methods. I forget the exact way to describe it, but it has to do with like the way S3 methods are sort of dispatched. But in effect, when you call this library, then a bunch of the dplyr verbs, like left join, mutate, summarize, whatever, those are all, for the most part, they are dispatched through DuckDB. And so they get the performance benefits and you don't really change much of your code. So if you want it to, you can always sort of restore, if you want things to return to the dplyr behavior, which should be identical, but you can always run methods restore. So I mentioned that like most things are supported, right? Left join, mutate, summarize. Not everything is supported, but the good thing about this package is, in my experience, it's been very explicit when it doesn't support something. And so, but in order to really give it the full set of warning messages, I would recommend calling this function fallback config info equals true. I think the default is false. So this enables fallback diagnostics. So it'll tell you, when you enable that, it'll tell you explicitly when it doesn't support something. And then when it doesn't support something, it just falls back and runs dplyr code. So you don't get the performance benefits, but you get the identical behavior, and really it's no worse than just running dplyr code. So I do want to get into, I don't know if I think I messaged this in the Slack channel actually about, I had presented on dtplyr and I found it pretty promising at the time. Then I tried it out and I got some like pretty in my opinion, some pretty bad errors that were kind of unacceptable, in my opinion. So I just want to elaborate more on that and why I'm not really using dtplyr. So I designed this example where basically dtplyr, you write some dplyr code, try to run it through dtplyr, and it silently gives you different results. So it gives you incorrect results, and it doesn't tell you that anything is different. So yeah, I thought that was a pretty big issue, and then it made me sort of not want to really use the dtplyr package. But the example goes like this. So I used a pretty obscure argument. This was sort of motivated by performance at the time. So there's this left join function, right? So you're joining in a table by the rows in the left table, but there's a multiple parameter. So this controls what happens when you have this situation below, where you might have like a table where you have like a key column, every value is unique. And then you're trying to join in the table where the key column doesn't have unique values. So it has multiple rows for this key. So at the time, I mean, this is a sort of, I don't want this to be a really contrived example, but this was something that actually this was a real use case that I'm trying to simplify down into sort of like a reprex here. So at the time I was joining in clustering results for some Visium HD data, where the clustering results had basically it was a barcode for the bin in Visium HD, which was represented by the key column here. And then it had for each of those barcodes, it had multiple genes. So there was multiple rows per barcode because there were multiple genes. And then there were also clustering results that one per barcode. So I wanted to join that in with the call data of a spatial experiment object. That's sort of what this example was getting at. And so rather than trying to deduplicate this table here, which was extremely large because it's Visium HD data and it has many genes per barcode, and there's millions of barcodes. So it got pretty huge. And I didn't want to sort of do a group by deduplicate. So I thought would be a little bit better in performance to do this multiple equals any option, where it says basically take the first key you see in the right table when you're joining. So basically take any of them, take any of these rows, because all I wanted was the clustering information. I didn't care about the genes at the time. So that was the use case. And so if you run this, I'm not going to run this interactively. I'm just going to walk through the vignette here. But obviously the keys vignette is just these unique values. The other data frame, like I said, has the keys duplicated with different genes. And when you do this left join, so we're just going to start doing with dplyr. So this is what you'd expect when you do a left join with this multiple equals any option, is you get one row per key. That's critical. And it just kind of takes the first gene that you have, because we don't care about the gene, we care about the cluster in this case. So that's what it's supposed to do. It takes one row per key. So you get 3 rows here. And so I tried to do this with dtplyr because I was like, well, this is a huge data set. I want to see if I can speed this up using data.table backend. So the way you do that, I covered this a while back doing in a session, but you sort of wrap it in this lazy DT function, wrap your data frame, and then you use dplyr verbs exactly as is. So we use this multiple equals any, and then what you do is you materialize it by calling as tibble. And so what that does is, yes, you get incorrect results. You get multiple rows for each key, which in other words, what happened is this multiple equals any was just completely ignored. And worse, there was absolutely no warning that it got ignored. It was a silent error. And so that was something, I feel like that in packages that are doing translations that you're trying to rely on for real research, it's, in my opinion, it's kind of like unacceptable to get this kind of silent mistranslation. So that was something I actually reported this as a GitHub issue, and it's still an open issue. But let's just show how like duckplyr, I tried this same example with duckplyr. I was curious what would happen using a pretty obscure parameter. So earlier we had called methods restore. So this is sort of like just making sure we're really paying attention to what we did earlier. So methods restore made it so that we just use the ordinary dplyr behavior. So now we want to use methods overwrite, which is sort of like the opposite of that. So now we're going back to duckplyr methods, and it gives you a little message saying that you can restore with methods restore. So now when we call left join, notice we're working with ordinary data frame, or ordinary tables really, and we're just calling the dplyr what appears to be the dplyr method for left join, but it's actually running the version from duckplyr. So multiple equals any. So as I've sort of alluded to, you do get the correct results. You get 1 row per key. So it did that. It did it exactly as dplyr did. So perfect translation there. But something else, if you notice, there's this little warning message. So it actually says like, I don't know what this multiple argument is. It's not supported. So what we're going to do is we're just going to run this left join method through dplyr. So you're not going to get the performance benefits, but it's telling you like exactly when it doesn't support something and running with the identical behavior. So I think this is exactly what I would want a package like this to do that's trying to do translations, is to first attempt a faithful translation and be very explicit when it doesn't translate something. So I think this is exactly what I would want out of a package. So I found this pretty promising here. So I just want to show like now, we'll go through like a workflow, a tiny workflow working with small data. Obviously, this is sort of a package where you would really, the reason to use it is for larger data sets and where performance is critical. But for this vignette, we just do a tiny data set. So we have some gene expression information in here as a tibble. So just writing a small CSV here. And then you might do some dplyr-based manipulation. Something I discovered actually was in generating this workflow was, for some reason, it's not, like if you try to do like a group by and then summarize, it says like that's not supported. So you have to do this like summarize.by parameter. So that was a little bit disappointing because it's like, I thought the whole goal was to write dplyr code as is and then have it run with a DuckDB backend. So I guess this is just like a warning that sometimes you will have to rewrite the syntax, which is unfortunate. But anyways, the workflow, it does support something really helpful as this read CSV DuckDB. So the actual reading of the file has the DuckDB backend. So that's useful because what it does is this is just like a query plan. So it's not even reading in the data. It's not filtering it. It's not summarizing it. It's just designing a query plan to compute when you actually need it. And then it can optimize that with a DuckDB backend. So I think that's the cool thing about this read CSV function is it's not actually reading anything in yet. So to actually materialize it as data, you would run basically this collect function. So collect is saying like, I want this result as a data frame right now. And so yeah, this is some sample data where the data is not super important, but this is sort of what this like a tiny workflow might look like. So here I do there's some other concepts in this package. One of them is called prudence. So one of the behaviors is that when you read like a really big data set, if it's too big, the default behavior, it'll actually say like, I'm not going to actually materialize this even when you do collect with certain prudence modes. So basically the philosophy is that it's trying to avoid unexpected large uses of memory that would basically get your process killed or lead to issues. So if you want it to behave exactly like dplyr and just not care how much memory you're using, really, I mean, it's still memory optimized, but it's not going to fail if the size is too big. So you would use prudence mode equals lavish, basically here. But there's also these thrifty and stingy options. But that's just like a little bit of a note. If you're interested in exploring this package more, you might want to look into like these prudence parameters. And yeah, I guess like this was pretty quick, but in summary, basically duckplyr is supposed to be a drop-in replacement for dplyr to get better performance. It's pretty transparent with when it can't translate something, and it does. It's been good in terms of translating things correctly in my opinion, my experience. You get this lazy execution and DuckDB optimization that's really helps get you performance gains. And yeah, that's like a quick walkthrough through duckplyr. So I plan to actually use this with some of the BusyMHD work I'm doing. And yeah, another thing is I had prepared this presentation pretty quickly and I didn't have time to actually do some performance tests to see like how much, again, with some of these packages, obviously the goal is like lower memory, faster runtime. So I think a next step is for me to really test out how much better this behavior you get with DuckDB. So from last time, from the DuckDB presentation, it seems like you might get like speed When I did it, it was like I think it was about twice as fast. And the big difference actually in memory is in the resident set size, the actual physical memory used in RAM. And from what I was reading, basically that's in Slurm. That's what leads a process to be killed is if you're physically using too much RAM rather than too much virtual memory. So it seems like when I was running this with DuckDB, you would get sort of similar virtual memory use, but it would actually use RAM more efficiently. So that's still helpful for at Slurm at JHPCE, where we are trying to minimize the actual physical RAM we're using rather than virtual memory. So that's sort of like a technical aside, but yeah, I think it seems promising so far, but I do want to get those numbers just to see if we're really getting some good benefits. And I'm curious more about like trying this more. I haven't tried this on a full use case because I sort of quickly discovered that you need to change some syntax. I'm kind of curious how many other things are like this, or whether it really is easy to use as a drop-in replacement. So that's still sort of feel like I need to investigate a little more. But yeah, I think that's pretty much what I had for today. And yeah, happy to take any questions. There's some more details I didn't cover today as well, like this memory projection stuff I sort of hinted at, but I didn't really go through it. So there's a little bit more about this package. This package seems pretty well built, and like there's a lot of also well documented. So lots of articles in here.
Nick, have you explored at all how this interacts with like SummarizeExperiment
SummarizeExperiment. So
or like a capital D, capital T data table?
oh yeah, that's a good question.
Yeah, because like I guess in regular like dplyr, like you have to like convert it to data frame, data t like or like a tibble for things to work as expected. It doesn't like the capital D, capital F data frame. I would expect if it's like supposed to be a clone of dplyr that like it probably has the same things, but like I don't know if you've messed around with that at all.
Yeah, so I think you would, I guess from like a performance perspective, I think you would have to, I don't know if there's any way to I'm suspecting that they don't support the capital data frame with,
Yeah, that's what I would guess too.
but yeah, I guess I would wanna, that's a good question. Because that's sort of, yeah, if you have to convert into like a table or something similar, like you might already be, like that might be I don't know if you get much performance gain if you have to do that. Um, yeah, I'll have to try that. Because yeah, I guess that's like one of our main use cases with like we have these big call data, capital data frames. Yeah. I guess I'll also mention one more thing. So just if you're curious, I was sort of the process I used for like creating this. I wanted to go sort of into the process I used for creating this markdown. So as I was exploring this package, I was mostly learning. I was starting to learn and test things through the documentation, which was really useful. It's pretty succinct as well. Like they get sort of right to the core things you need to know. So as I was learning more of these things, I was sort of integrating different concepts I was learning. And then I actually did I guess I sort of used AI to generate some of this R Markdown, just for the transparency. And also sort of I guided it through rather than say like, just generate something related to duckplyr. Obviously, I didn't do that. This was more sort of guiding it, prompting the model to sort of go through a very specific curriculum that I sort of established for it by describing like, oh, I want to describe the overview of duckplyr, how it differs a little bit from dtplyr, a use case where left join multiple equals any doesn't give the expected behavior, and then concepts about prudence, as well as an end-to-end workflow. So that helped me sort of get like a vignette together, but sort of guided it through based on the curriculum that I thought would be useful for today. But that's just like a little note if anyone's curious, but because I know as we talk more about AI and stuff, if there's no other questions, I think that's it for today. So yeah.
Cool. Looks really useful, Nick. Thanks. Thanks for exploring it and also like the difference between our options here.
Yeah, there are a lot of options. And so I think this one's a good one.